Have you ever stopped to think about what actually happens when you click a link? I mean, it feels instant, right? But behind that one simple click is an absolutely incredible, high-speed journey. So let's follow a piece of data and see where it goes. Yep. Everything we do online, ordering food, watching a movie, you name it, it all begins just like this. One simple, almost subconscious action, a single click. In that tiny, tiny fraction of a second, your computer kicks off this super complex chain of events just to grab the information you asked for. So what's really going on in there? For this explainer, we're going to make that little data request the hero of our story. We're going to follow it from your computer, out across the huge sprawling internet, all the way to a server, and see exactly how it gets there, and just as importantly, how it gets back. Okay, so the whole journey kicks off with a process called encapsulation. Now, the best way to think about this is like sending a letter through the mail. You can't just send the letter, right? You have to put it in an envelope with an address. Well, the internet does something kind of similar, but it wraps your data in multiple envelopes, and each one has a very specific job to do. Let's break down that packing process. It all happens in layers. First, you've got the application layer, which creates the actual data. That's your request to see a website. Then that data gets passed down the line, and each layer below wraps it in a new digital envelope, adding its own special instructions for the trip. So that first envelope comes from the transport layer. Its main job? To add a port number. Now, if you think of the final destination IP address as, say, a big apartment building, the port number is the specific apartment number. It tells the computer on the other end exactly which application should get the message. For secure websites, that number is pretty much always going to be port 443. Now here's a kind of funny thing. As our data gets wrapped in all these different envelopes, its name actually changes. At the transport layer, we call it a segment. Once the network layer adds its info, it becomes a packet. And finally, at the data link layer, we call it a frame. It's still the same data inside, it just gets a different name at each step of the packaging process. All right, next up is the network layer. This one is a big deal. It adds the most important address for the whole long-distance journey, the server's IP address. This is the main global destination. And once that's slapped on, our segment officially becomes a packet. The last piece of the puzzle comes from the data link layer. Now, this layer is different. It doesn't care about the final destination way across the world. It only cares about the very next hop, like your home router. It adds a local address called a MAC address, and boom, our data is now a frame, fully packed and ready to hit the road. And we are off. The frame, which at this point is really just a stream of electrical signals or pulses of light, travels from your computer through an Ethernet cable or Wi-Fi to the very first piece of networking hardware it meets, which is usually a switch. So our frame is about to meet two really important but very different devices, a switch and a router. A switch works at layer 2. It only thinks about the local neighborhood. It uses those MAC addresses to ask, where's the next immediate stop? A router, on the other hand, is a layer 3 device. It thinks about the big picture, the final IP address, and its job is to figure out the best long-distance route across the entire internet. So when our frame gets to the switch does one simple thing. It looks at that outermost envelope, reads the MAC address for your local router, and just sends it along. It doesn't even peek at what's inside. Now this is where the real magic happens. The router gets the frame. It rips open that outer envelope to look inside at the packet's IP address. Then it checks its internal map of the internet and says, okay, to get to this final destination, the best next place to go is that router way over there. Then it wraps the packet in a brand new frame with a new MAC address for that next router and sends it on its way. This exact process happens again and again, from router to router, all across the internet. After hopping across maybe dozens of these routers, flying through undersea cables and massive data centers, our little frame finally makes it. It arrives at its destination, the actual computer that hosts the website you asked for. So it's arrived. Now the server has to figure out what it just received. It does this through de-encapsulation, which is just the exact reverse of what your computer did at the beginning. It starts unwrapping all those envelopes one by one to get to your original message. The server basically runs through a quick security check as it unpacks. First, it looks at the outer frame. Is this MAC address for me? Yep, it unwraps that. Then it checks the packet's IP address. Is this for me too? Yep, unwraps that. Then it reads the segment's port number, 443, and knows, this message is for my web server software. finally, it hands your original data to that application. Success! After all that unwrapping, the server has your original request. It knows you want to see its homepage, and it gets everything ready to send that page right back to you. And here's the truly amazing part. To send you that web page, the server does everything we just talked about, but in reverse. It encapsulates all the website data into segments, packets, and frames, and sends it all on the long journey back to your computer. Your machine then de-encapsulates it all to show you the page. And this whole round trip happens in milliseconds. It's just incredible.
So, why? Why go through all this trouble with these complicated layers? Because it's a brilliant system. Each layer has one and only one job to do. This creates a universal language, a standard that any device from any company can understand. It means you can have an old computer and a brand new router, and they just work together. It's a system that's both incredibly complex and beautifully simple at the same time. And that's the packet's journey. This layered model is the fundamental reason a phone in Tokyo can talk to a server in Toronto seamlessly. It is the language of our connected world. Which kind of leaves you with a final thought, right? What other massive global challenges could we solve if we could just design a universal, layered language for them too?